Okay, let's give you guys some more practice. So use trigonometric substitution to integrate this. So press pause and have a go. Okay, so to do this, visualize this bit here as this. Visualize it as this. So you've got that same thing, a squared minus x squared here. Visualize it as to the power of 1, and then times by itself. So this a squared minus x squared to the power of a half. So that's the same as this thing here, and then square root of that same thing here. A squared minus x squared, a squared minus x squared here. So visualize this thing here as this. So visualize this thing here as this. Okay, so we are trying to integrate this, but visualize this thing here as this thing here. So now your eyes should zoom into this bit here, and then create your right angle triangle in such a way, create your right angle triangle here in such a way that this will be true. You see, if you make the hypotenuse be a, the opposite to be x, then the adjacent here will be this thing here. So in order for you to integrate this, your eyes should zoom into this bit here, and then create your triangle in such a way that this is true. Create your triangle here, and then from your triangle you can create this, because looking at the triangle here, sine theta would be this. So sine theta would be opposite over hypotenuse. So sine theta equals this, times both sides by a, that will then give you this. So now differentiate both sides. So this thing here will be this, and differentiate this will give you this. So now you've got dx equals this thing here. So we can put this into the dx up here, and then from the you now need a way of replacing this complicated thing here. Well, to replace that complicated thing here, you would look at your diagram and somehow look at your diagram. If you look at this here, hang on. If you look at cos, cos theta will be adjacent over hypotenuse. So you're trying to isolate this thing here. So times both sides by a, that will then give you this. So now this complicated thing here, we can replace it. So this thing here, we can put it into here, and then this bit here is really us recycling this. So if you just want this bit without the square root, then what you do is you square both sides. So currently we are here at the moment. So what you do is you square both sides. So if you square both sides, you will get this: a squared cos squared theta equals a squared minus x squared. So now if you look at this here, this is exactly the same as this. So we can substitute this into here. Okay, and then the x squared part, well, you would then look at this here. Currently x equals this, so what you do is you square both sides. So that will then give you this. So now we can put this into the x squared here. Okay, so this whole thing here will then become this. Will then become this. Okay, so the whole thing here will then become this. Tidy this up, so it's this cancels out, and then you've got sine squared over cos squared, which is in effect tan squared. So now it's just a matter now of integrating tan squared. So in order for us to integrate tan squared, we've done this before in the past. So remember, by the way, we've done this before in the past. To integrate tan squared, you would start out with this: divide both sides, divide everything by cos squared of theta. That will then give you this. So tan squared is really the same as secant squared theta minus 1. So we would replace this with this thing here. So to integrate 10 squared, we would write 10 squared as this. So now it's just a matter of integrating this. And again, we've done this before. To integrate secant squared, well, just remember that, well, in order for you to integrate this, we've done this in the past, by the way. In order for you to integrate this, if you try and differentiate 10 squared, in order to integrate this, if you differentiate tan of x or tan theta, if you differentiate tan, you would get this. We've done this in the past. If you differentiate tan, you would get secant squared. Okay, so if you want to integrate secant squared, then you would work backwards to give you tan. So the point I'm trying to make here is that if you want to integrate this, it will be tan. Integrate this, and it will be tan. Okay, so if you integrate this, it will be tan, because when you differentiate tan, it will give you secant squared. So if you go the other way, well, integrate this, it will give you tan theta. So we are currently here. If you integrate this thing here, it will give you this. It will give you this. Okay, so this is our answer here. But the thing is, we don't want the answer in terms of theta. We want it to turn it back into in terms of x. So we need to translate theta back into x. So now go back to your diagram from above. Look at your diagram, and then try and find a way of translating this and this. You see, from the diagram we can obtain this, and this was our diagram from above. So from the diagram, sine would be x over a, sine would be x over a, and then tan would be this, would be opposite over adjacent. So now remember, we got to this stage here. We need to find a way of translating theta back into x. So if you look at this here, tan theta is really this thing here. So we can put this into here, and theta, you can either use this or you can use this. Select the simplest one. So select this one here. So if you want to know theta, then look at this. Inverse sine equally to both sides. That will then give you theta equals inverse sine of x over a. So now we can put this into the theta here. Okay, so this whole thing here will then become this. Okay, so this is our final answer.